Hi everyone, I'm Sujal Adhikari and I'm from Group 63. So in my team, I have Anirudra Basnet, Yuvraj Singh, Sanjay Gapsov as my team member. And in this presentation, we will be talking about different investigations regarding the impact of digital screen time on adolescence and well-being. And the overview of a data set will be regarding the reduction of digital screen time affect well-being, and the objective will be to find out the impact of reduction of digital screen time to well-being. So to describe about the first investigation through descriptive statistical analysis, I would like to call Mr. Yuvraj.
Hello everyone, my name is Yuvraj Singh. Today I'm going to start with my first investigation on descriptive statistics. In this analysis, I calculate the average screen time by demographic variables such as gender, minority status, and deprivation. After calculating the average, I plotted graph to visualize the distribution of screen time to show comparison between different groups of demographic variables. Now let's start with code. Very first, I imported Panda library, which is widely used for data manipulation and analysis. After that, I imported a plot module from Matplotlib library, which is widely used for animation and visualization. After that, I load all the three datasets which we are required in our code. After that, I merged all the three datasets in merged underscore df variable. After that, I calculate average screen time by gender. Here, we use group by variable to group average screen time of all variables according to gender differences such as male and female. After that, we do the same with minority status and deprivation level. After that, I print all the three results. Then after, here we are using bar chart to visually represent our result. After that, the meaning of this line is that we are going to plot bar graph for data frame gender underscore screen underscore time. Then after we do same with minority screen time and depraved screen time. So let's run the code. Here you can see average screen time by gender. For male and female they are different. Same for minority and same for depraved. Both are different. Thank you. Now I am handovering the presentation to Anirudh Basnet. Thank you.
Hello everyone. Today I'll be discussing the distribution of various well-being indicators based on the dataset we've analyzed. The main goal is to visualize how people rate their well-being across different categories. In the first part of the code, we use the pandas library to load these datasets into data frames. Dataset 1, 2, and 3.csv. After loading, the datasets are uh, merged on the basis of a common identifier called ID. This ID is unique to each respondent, ensuring that their responses from each dataset are combined correctly. The core of this analysis is visualizing the distribution of histograms using matplotlib.pyplot. We do this by generating histograms. Each column in the dataset represents well-being indicator, and the code creates individual histograms for all 13 indicators. To run the code, uh, we get this graph that I have uploaded in the presentation. The x-axis of each histogram represents the range of scores people give for that well-being indicator, typically ranging from 1 to 5, and the y-axis represents the number of people who gave each high score. These histograms allow us to see how people are distributed across different well-being levels. Most well-being indicators show a pattern where the majority of the people rate themselves in the middle, or slightly above average, around 3 or 4. Uh, this suggests that people generally perceive their well-being as moderate to high. To conclude, the analysis of these well-being indicators gives us a powerful way to understand how people perceive different aspects of their mental and emotional health. The, these histograms we've generated provide a clear visual representation of how people rate themselves on various well-being measures. And now I would like to pass this to Sujval Adhikari once again.
In this presentation, I have done investigation on confident interval of screen time on weekdays and on weekend. So let's go on formula. First I find the total screen time of a weekdays of CWE, GWE, SWE, and TWE. In which some x is equal to 1 is used to add the value in the same row across a different column. Then I have found the mean and standard error using a mean function and the same function. Then I have calculated the confident interval of a weekdays screen time, in which I assume 95% confident interval, so that the confidence level is 0.95, and these all are the basic formulas. So degree freedom is equal to n minus 1, in which df mod minus 1, and to find t value using a stat dot t dot ppf, which will get a critical value. And it is important for the margin of error. Now margin of error can be found from the product of t value and standard error. And then I have calculated the ci lower and ci upper. It's just formula such as mean screen time minus margin of error for ci lower, and mean screen time plus margin of error for ci upper. Then I have printed the mean of weekdays screen time and the confident interval of weekdays screen time. So to find the confident interval of weekend, it is similar as finding confident interval of weekdays, in which we have to replace weekdays from screen time of weekend. So the CW, the GW, SW, TW. Then we have to follow the similar step to, calculating mean from mean function and same function, and calculating confident interval of weekend screen time. Confident level is equal to 0.95. Now we have to find the degree of freedom t value and margin of error, which is t value into standard error. Then we have to calculate the ci lower using the formula, this formula. And at last I have printed the mean of weekend screen time and confident interval of weekend screen time, and these are the results. So from this we have find the mean weekdays screen 8.21, mean weekend screen time 11.08 hours. And this finding shows that average screen time of weekend is more than the weekdays, and the confident interval between the weekdays and weekend are relatively narrow, which estimate that mean screen time are accurate and reliable.
Hi, I'm Sangi Jamsu and I'll be discussing briefly about investigation 4, which is t-test for comparing well-being for different level of screen time. My main objectives of the investigation is to find out an impact of reductions of digital screen time to well-being. Well, I've used this code to carry out the investigations, and directly I'll be discussing about the hypothesis testing. So the data frame is split it into a two group based on the screen time on weekends. The first one is low screen times, which include the respondents with the screen times less than or equal to 2. The high screen time include respondent with the screen time greater than 2. So after that, I perform the t-test for t statistical of the test and the p-value of the test. Then after getting ready with this code, I have printed the result. If the p-value is less than if p-value is less than 0.05, the result is considered statistically significant, meaning there is evidence to suggest that reducing screen time significantly affect well-being. If otherwise, if the p-value is greater than or equal to 0.05, the result is not considered statistically significant, meaning there may not be enough evidence to conclude that screen time reduction affect well-being. So I found that t statistic value of test and the p statistic value of test, and in the next slide I will discuss about the result. After running our code, we are with result that screen time versus well-being. TTS for comparing screen time and well-being shows that reducing screen times on weekend lead to a statistically significant improvement in optimism, because we already know the t statistical value and p values. From this result, we can confirm that there is a meaningful effect of reducing screen time on overall well-being. Finally, after carrying out this 4 investigation, we came into conclusion that reducing screen time, especially on weekend, can significantly improve well-being, and secondly, limit smartphone use during weekdays as it negatively impact mental health indicators such as optimism. Our group also suggests or recommend that further research is needed to understand the long-term effect of screen time on adolescent well-being.